Sine Rule. In this module, you will learn about law of sines or sine rule. Let us first state the sine rule. The sine rule states that the lengths of the sides of a triangle are proportional to the sines of angles opposite to them. This means that if the given triangle is ABC, then we have A over sine A equal to B over sine B equal to C over sine C. To prove this, we have to consider three cases. Case 1, when the triangle ABC is an acute angled triangle. Case 2, when the triangle ABC is an obtuse angled triangle. Case 3, when the triangle ABC is a right angled triangle. Let us first look at case 1. Case 1. When triangle ABC is an acute angle triangle, let A is equal to BC, B is equal to AC, and C is equal to AB. From the vertex A, draw a perpendicular AD to BC. In the triangle ABD, AD over AB is equal to sine B. Since AB is equal to A, thus we have AD is equal to C sine B. Let this be equation 1. Also, in the triangle ACD, AD over AC is equal to sine C. Since AC is equal to B, thus we have AD is equal to B sine C. Name it equation 2. Now from equations 1 and 2, we get C sine B is equal to B sine C. Or we have B over sine B is equal to C over sine C. Let this be equation A. Similarly, by drawing BE perpendicular to AC, we can prove that A over sine A is equal to C over sine C. Name it as equation B. Now, from equations A and B, we have A over sine A equal to B over sine B equal to C over sine C. Let us now consider case 2. When the triangle ABC is an obtuse angle triangle, from the vertex A, draw AD perpendicular to BC produced. In the triangle ABD, AD over AB is equal to sine 180 degrees minus B. This implies that AD over AB is equal to sine B, or AD is equal to C sine B. Let this be an equation 1. Similarly, in the triangle ACD, AD over AC is equal to sine C. This implies AD is equal to B sine C. Let this be equation 2. Now from equations 1 and 2, we have C sine B is equal to B sine C, or B over sine B is equal to C over sine C. Similarly, by drawing BE perpendicular to AC, we can show that A over sine A is equal to C over sine C. Hence, we have A over sine A is equal to B over sine B is equal to C over sine C. Lastly, let us consider case 3. When the triangle ABC is a right angle triangle, we can see from this figure that the triangle ABC is right angled at B. So we have the following. AB over AC is equal to sine C, or C over B is equal to sine C. This implies B is equal to C over sine C, and BC over AC is equal to sine A, or A over B is equal to sine A. This implies B is equal to A over sine A. Also, sine B is equal to sine pi over 2, which is equal to 1. Thus, B over sine B is equal to B. Now, from 1, 2 and 3 we have B is equal to A over sine A equal to C over sine C equal to B over sine B. This can also be written as A over sine A equals B over sine B equals C over sine C. From all the three cases, we conclude that A over sine A equals B over sine B equals C over sine C. Note here, if this is equal to K, then we have A is equal to K sine A, B is equal to K sine B, and C is equal to K sine C. Also, if this is equal to lambda, then we have sine A is equal to A lambda, Sine B is equal to B lambda and sine C is equal to C lambda. These can be used in solving problems. Let us consider an example to understand how the sine rule can be applied. In a triangle ABC, if A is equal to 2, B is equal to 3 and sine A is equal to 2 over 3, then find angle B. Since we know that here A is equal to 2 and B is equal to 3 and sine A is equal to 2 over 3, thus we have 2 over 2 over 3 is equal to 3 over sine B. This implies that sine B is equal to 1 or B is equal to pi over 2 or 90 degrees. In this module, you have learnt about law of sines or sine rule.